factor if possible. If not possible, just write prime. Is number 1 factorable?
Yes.
Okay, so what are my factors here?
X plus 11.
X plus 11, x minus 3. Good. If I solved that, what would be my solution? And positive 3. Very good. What about the second one? Prime. If it was positive 6x, it would have worked. It's not. Positive 8. Okay. So we could solve number 1. We couldn't solve number 2 by factoring, but what I'm going to show you guys today will help you solve number 2 a different way. So I'm going to, you guys don't need to write this down, we're going to work through it together. I have 5x plus 2 equals negative 3x squared. I need to get my a, b, and c values, but I can't do that until it's in standard form. So to get it to standard form, what needs to happen? Move the 3x squared to the other side. So add 3x squared. So we get 3x squared plus 5x plus 2 equals 0. What's my a value? 3. What's my b value? And my c? 2. Okay, so now we're looking at the same problem. My a is 3, my b is 5, my c is 2. This is called the quadratic formula. The quadratic formula works for every single quadratic as long as it's in standard form and as long as it equals 0. Okay, so even though it works for every single problem, I don't have everybody's attention. Even though it works for every single problem, that does not mean that it's the best route. Okay, quadratic formula, as you can see, is time consuming. That doesn't look like it's going to be real fast, does it? No. It's quite possibly one of the longest routes to solve, but it is a good route if you're looking through it, like number 2 that we just talked about, and it's prime, I can't factor it. I could solve it a different way that we're going to talk about next week, but I can't solve it using square root. So if I can't factor it, I can't solve it using square root. I need another route. If there is a solution, if you graph it, it will have 2 intercepts. So let's take this problem. First of all, is this problem factorable?
Wait.
3 times 2. Factors of 6 that have a sum of 5. 3 and 2. So it's factorable. If I have factors of 3 and 2, that means that I could solve this quickly by factoring. Wait, that's wrong. So, 3x squared, and this is 2. Okay, so what kind of factor out here? 3x, good. So then what would this be? X, what would this be? 2. And what would this be? 1. So my factors are 3x plus 2 and x plus 1. So what are my solutions? X equals negative 1 and x equals negative 2 over 3. So I'm going to get the same solutions when I use this. So if I was taking a test after we finished all of our different ways to solve, I would not be using the quadratic formula for this, but I could, yes. Because if I set 3x plus 2 equal to 0 and solve, what do I get? Minus 2 divided by 3. Yeah. Okay. So let's use this formula. Negative b. Well, what's my b value? 5. So what's negative b? -5. So -5 plus or minus the square root of b squared. So 5 squared minus 4 times a, which is, times c, which is 2, all over 2 times a, which is 3. You could, yeah. There's a lot of ways that your calculator can mess this up, so try and simplify it. What's 5 squared? -4 times 3 times 2, -24. 2 times 3, 25 minus 24. So -5 plus or minus the root of 1 over 6. What's the square of 1? 1. -5 plus or minus 1 over 6. -5 plus 1. Divided by 6. -2/3. -5 minus 1. -6 divided by 6. -1. Is that what I got with factoring? Yes. So another route to solve the same thing. It took me a little bit longer. Okay. So what type of scenario might give us a no solution answer? What if I would have had that? What if I reversed it? 24 minus 25, what would that have given me? Let's put that in your calculator. Square root of -1. Error, right? Because a negative is created by the product of a positive and a negative value. So there is no number times itself, or real number. There is no real number times itself that will give you a negative, okay? So if the radical is a negative, so if you're doing the quadratic formula and you hit this step right here, and the value inside the radical is negative, you're done because there is no solution. How does the positive negative in the formula affect my answer? It gave me 2 solutions. It separates it into 2 different equations, just like solving most square roots. All right, so now on to your notes. So this is in front of you. 2x squared minus 3x minus 3. So, like I said before, your equation has to be equal to 0 for this to work. Just like if you were solving by factoring. Has to equal 0. So far so good. 2x squared minus 3x minus 3. What's A? 2. B? -3. C? -3. So we're going to substitute our values into our formula. So they've got it nice and set up for you, so we just have to plug things in. So -b, well, what's my b? -3 plus or minus the square root of b squared. So what's -3? What's going to go here? 2 and -3 all over 2 times a. So what goes in here? 2. Now we start to simplify. -3. Just 3. Plus or minus the square root of -3 squared. 9. -4 times 2 times -3 plus 24, because those negatives canceled out, right? So plus 24 all over 2 times 2, or 4. All right, so now let's keep simplifying. 9 plus 24, 33. Can I simplify the root of 33? By what? 11 and 3. Are either of those partners?
No.
No. So can I simplify it? No. This is my answer. That is a scenario that could not have been factored. If you get an answer with a radical, you could not have factored it. All right, let's do example B. 2x squared minus 9x minus 5. What's my A value? 2. B? Negative 9. C? Negative 5. Okay. So our formula, negative B, 9, plus or minus the square root of B squared, negative 9 squared, which would be what? 81, minus 4 times A, which is 2, times C, which is negative 5, all over 2A. So what would go on the denominator? 4. 2 times 2. All right. We've got to simplify some more because I've got all this stuff going on here. Negative 4 times 2. Negative 8 times negative 5. Positive 40. Okay. So 9 plus or minus the root of 81 plus 40 over 4. What's 81 plus 40?
121.
121. We got lucky. That's a perfect square. So 9 plus or minus the root of 121 over 4. What's the root of 121? 11. So 9 plus or minus 11 over 4. 9 plus 11? 20 over 4. 5. So there's one solution. 9 minus 11, negative 2 over 4, negative 1 half. Looking at those answers, could I have factored that?
Yeah.
Yes. Anytime you have a whole number or a fractional answer, you could have factored. Okay. Okay. I'm going to do a couple of specific problems with you. I'm going straight down to the practice that's inside the table. All of y'all are inside the table. Okay, so looking at number 2, x squared plus 4x plus 1. Is it ready to plug into the formula? Yes. Yes, it equals 0. That's how we know it's right. What's my A value? 1. B, 4. I'm doing number 2. C, 1. Okay. So, negative B, help me out. Negative 4 plus or minus the square root of B squared, 4 squared, 16, so negative 4 plus or minus 16, minus 4 times A times C. What's negative 4 times 1 times 1? Negative 4. All over 2A. So what's my denominator? 2. So I have the expanded version up on the board. So this is expanded, that's simplified. Now, 16 minus 4. 12. So negative 4 plus or minus the root of 12 over 2. Can I simplify the root of 12?
Yeah.
No.
Oh. Yeah, 2 outside.
2 root 3.
That's not.
No, it doesn't have to be a perfect square. Root 12 6, 2, 3, 2. 2 root 3, yeah? Okay, so -4 plus or minus 2 root 3 over 2. May appear as if we're done, but we're not. We're not done because I have multiples of 2. So I'm going to simplify. If I had -4 over 2, would you leave it like that? What would you turn it to? -2. If you had 2 root 3 over 2, would you leave it like that? No, what would you turn it to? Just root 3. The 2's cancel out. But when you have addition or subtraction creating multiple terms and over a denominator, that means that each term has to be simplified by that denominator. So essentially what I'm doing is I'm combining these. So -4 divided by 2 is -2, and 2 root 3 divided by 2 is just root 3 with your plus or minus in there. So I have simplified it, and that is my answer. So when you have a radical, you need to double check the first term, so that -b, the coefficient of your radical, can they both simplify by the denominator. So if I had a scenario that looked like this, you don't have to write it down. If I had a scenario like this, I can't simplify that. Why would I not be able to simplify that? The 3, they both have to be divisible. If I had -8 plus or minus 4 root 4 over 2, that works. They both have to be divisible. Okay. Number 5. I'm doing these specific problems for a reason. So number 5. Can I go ahead and plug it into the formula the way it is?
Yes.
Yes, it equals 0. There are no other guidelines. It just has to equal 0. What is my A value?
2.
B. C.
4.
Yes, sir.
There's ever a GCF, you back up GCF.
You can, but you don't have to for quadratic formula. You can just plug in and do it. All right. So, -b plus or minus the square root of b squared. 25 minus 4 times a. A times 4. -32 over 2a. So what's my denominator? 4. Okay, so now I can simplify. -5 plus or minus the square root. 25 minus 32? -7 over 4. Okay, what's the root of -7? None. That's a no-no. No solution. It's actually no real solution. Because in algebra 2, you will find that solution, but it's not a real number.
What do you mean it's not a real number?
It's an imaginary.
You say that? Wait. You just say that.
Okay, so it says for 6, and 7, there are no square roots left to simplify it as a decimal. First of all, we're not going to simplify it as a decimal. We didn't simplify it as a decimal here. Scenarios where you will simplify the decimal is real world scenarios where they're asking you about time. You're never going to tell somebody that the time is -2 plus or minus the square root of 3, right? Okay? So real world scenarios, you can just plug it into your calculator and go. All right? But if I'm just asking you to solve using the formula, then you need to simplify the radicals. Okay, so your task is just to complete 4 more of the problems on that page. 4 more, and then you can be done for the day.